Mubin, and I'm here with my partner Krishna Saket. We have designed a project for the protection from seizures. It's basically an airbag which gonna help patients who are suffering from airbag to prevent any injury. So here we go. Basically, what are seizures? Seizures are symptoms of a brain problem. Happens because of a sudden abnormal electrical activity in the brain. And when people think of seizures, often they think of convulsions, in which a person's body shakes rapidly and uncontrollably. Well, in seizures, basically the person tends to fall on the ground and he will be out of consciousness, and this will last for 30 seconds to 2 minutes, and this is one type of seizures which we have understood and designed a project of an airbag which gonna help people to prevent accidents when the seizures are being occurred in the patient's body. So epilepsy, it's a condition that affects 0.6 to 0.8% of the population. It's a common neurological disorder after the stroke. So this is one of the example of the seizures, which is 0.6 to 0.8% of the people are affecting from it. And in seizures, how does the injury occur is the main question that will arise. Basically, when a seizure occurs, the patient will fall backward or frontward, and in that situation he will hit his head on the ground, which can lead to major injuries. So to prevent that injuries, we have designed uh, an airbag which will prevent this from happening. So as existing theory, no such projects have been come up, and this is one of the projects which we have been working on. And what is the proposed theory now? The person affected with seizures may suddenly fall down, as I said, and when the person falls down, he will be facing a lot of pressure on his head if he hits on the ground. So just to prevent from it, we have designed this airbag. So what we're gonna do is we have a vest jacket where the airbag is connected to it, and we have some sensors which we're gonna discuss soon. So with that communication of signals, we're gonna make it happen and prevent head injury. So what are the components that we are using here? We are using microcontroller ATmega 328, accelerometer, ultrasonic range detector, vest jacket, airbag, CO2 gas cylinder, push and pull solenoid, relay, and a battery which is of 12 volts. So this is the basic block diagram where the accelerometer and the ultrasonic range detector gives signal to the microcontroller, and the microcontroller in return gives signal to the airbag, which opens up the airbag by using the CO2 gas cylinder, relay, and solenoid. So this is the accelerometer which are using. Its name is MPU6050, and on the other side it's ultrasonic range detector, which detects the uh, space, which detects the distance between the ground. These both have to work in alignment so that the both functions will lead to the opening of the airbag. The accelerometer, it's a three-axis accelerometer, and the ultrasonic range detector, it measures the distance, and the accelerometer measures the movement, and this is how it works. So as I said about the ultrasonic range detector, uh, this is it looks like this, as I said, and the ultrasonic range detector will measure the distance from the vest jacket what we are wearing to the ground, and as soon as the ultrasonic range detector detects the distance that which we have specified, it opens up. It gives signals to the microcontroller, and this is how it works. And this is the program which we have done of ultrasonic range detector. As you can see, and the LOD is glown when the range is less than 100 centimeters. So we have designed a program of 100 centimeters. So this is done by using Arduino IDE. So this is the algorithm, and how we are connecting to it. There are a few various steps we had followed, and yeah. So as you can see how this algorithm is being carried on, the programming of the part, and this is the flow chart of how this accelerometer and ultrasonic range detector are functioning. As you can see in the picture, and the program of ultrasonic range detector is done by finding the distance that is suitable to determine the fall. So as I said, it measures the distance and it gives the value to the Arduino or the microcontroller, and in return it performs a function. So as you can see, when a hand is placed beside the ultrasonic range detector, which is on the left, you can see the distance is lesser than 100 centimeters, and the LED is glown. And on the right side of the image, you can see another LED is being glown. This is because of the accelerometer. Uh, tap the when we tap the breadboard, yeah, when we tap this breadboard, it detects the motion. Basically, as I said, it's a 3-axis accelerometer. When we tap on the floor or any surface, it detects the motion. It's basically detecting when a person falls on the ground. Yeah, so as I said about the accelerometer, we are using 3-axis accelerometer, and the name is MPU 6050. So this is how the programming of the accelerometer is done. As you can see on the screen, we are using X, Y, and Z axis for the accelerometer, and we are using the various values, and we are using if X axis greater than 150, the statement of number 10 you can see. So this is another flowchart of accelerometer, and this is how it goes. So the programming of accelerometer is done in Arduino. 3-axis readings are observed in the serial monitor. As you can see, there is a glowing of the light, and the accelerometer is attached to the breadboard. This is the programming of the accelerometer, which you can see on the screen. So we are giving a threshold value which is usually less than 103. It determines it and it opens up. So CO2 cylinders. Basically, these cylinders are very small in size and they are filled with CO2 in them. You can know by the name itself, and they are 16-gram cylinders which produce 8 liters of CO2 gas. And the size is very small. It's about 17.8 into 15.2 and 2.5 centimeters of dimensions. So this is how it looks. They are about 6 centimeters and weigh about 250 grams. Solenoid. What is basically a solenoid is nothing but it's made up of a big coil of copper wire with an armature in the middle. So when this coil is energized, the slug is pulled into the center of the coil, and it makes a motion of pull or push from one end or the other. As you can see, this is a solenoid. The technical details are basically it's a 12-volt DC operation and a push or pull type with a 5 mm throw. And DC resistance is 40 ohms, and 5 Newton starting force 1.4 Oz by 39 grams. Relay. These are the switches that opens and close circuits electromechanically or electronically. Relay diagram show when a relay contact is normally open, there is an open contact when the relay is not energized. So this is a relay. We can see in the image. Relays can control large voltages and amperes by having an amplifying effect, because a small voltage applied to relays coil can result in large voltage being switched by the contacts. So this is a major component that we are using. The controlling of voltage is done by this. So the working. Now I'll explain you how the working is done. First, the ultrasonic range detector detects the distance between the ground, and the accelerometer uh, detects the movement which we have programmed. When these both the functions takes place, it gives signals to the motherboard. It's nothing but Arduino, and that process it, and it gives signal to the solenoid, and the solenoid is connected with the needle, and the needle pop, and the other side of the needle there will be a CO2 cylinder. So when the solenoid gets the current from the Arduino, it pops a hole in the CO2 cylinder, and the gas will come out, and the gas will come out. The gas which comes out, it fills the air bag as it is connected near to it. As you can see here, this is how the whole process looks. On the bottom you can see a CO2 cylinder, right bottom, and just beside that there's a solenoid, and the black color which you see in the center is the battery, and just beside the battery there is a relay which control large voltages, and it controls the voltages and give it to the solenoid. And on the left side you will see an Arduino board and a breadboard where we have given the necessary connections. And the other side, instead of using a laptop, we have um, designed a circuit battery which gives power to the Arduino. So the final conclusion is, the persons who are suffering from seizures can be saved by causing any type of head injuries, and the person need not to monitor the patient all the time. They can be tension free. So the project can at least save some lives which are lost due to injuries caused during seizure sessions. Thank you. This is Mohammad Mubin and Krishna Suket. The project is done by us. Thank you.